Chapter 8 is about polygons. In lesson 8.1, we're going to talk about the angle sum theorem for polygons. We'll find interior and exterior angle measures and the number of sides given angle measures, and then we'll solve some contextual problems. In a polygon, two vertices that are endpoints of the same side are called consecutive vertices. And a diagonal of a polygon is the segment that joins two non-consecutive vertices. So in this case, if I look at polygon ABCDE, what I notice is that connecting A to B gives me a side of the polygon, and from B to C gives me a side of the polygon. But BD and BE are called diagonals of the polygon. When I connect two non-consecutive sides, it forms diagonals. So I want you to take a piece of paper and use a straight edge to draw some sort of convex polygons. Actually do two or three of them. Do a triangle, rectangle, a pentagon, a hexagon, heptagon. Make 4 or 5 of them, and then in each polygon, draw all the diagonals from just one vertex. Just pick a vertex and draw the diagonals that you can draw from that vertex. And then use what you can to fill out a table like the one below for the type of polygon of a triangle. It's got 3 sides. And when I draw that diagonals, I see that what I end up with is triangles. Well, with a triangle, I have no diagonals, so I only have one triangle. We know that the sum of the interior angles of one triangle is 180 degrees. For a quadrilateral, when I draw my diagonal, I can draw 1. It divides that quadrilateral into 2 triangles. And so if I wanted to find the sum of the interior angles, I might notice that all of those add up to be the angles of the polygon themselves. So I would do 2 times 180 because I have 2 triangles. So you should try it with a pentagon and a hexagon, heptagon, and so on. And then make a conjecture about an n-gon if any number of sides. What we find out when we do that is that a polygon's interior angles always add up to be 180 times n minus 2. So if the number of sides of the polygon, say a pentagon, is 5, then it will be 3 times 180, because when you have 5 sides, when you draw your diagonals, it forms 3 triangles, and so I would have 3 times 180. So find the sum of the measures of the interior angles of a convex octagon. Notice what I would do is, excuse me, I would find one vertex and I would draw all of the diagonals from that one vertex. And notice in that octagon I can draw 1, 2, 3, 4, 5 diagonals, which gives me 1, 2, 3, 4, 5, 6 triangles. So according to our polygon interior angles theorem, then what I can do is I've got 8 sides minus 2 gives me 6 triangles times 180 degrees, so I have 1080 degrees for the sum of all the angles in the triangle, or in the polygon. The sum of the measures of the interior angles of a convex polygon is 900 degrees. So how would I classify that polygon? Well, I'm going to use the same idea. I'm going to write my equation. 180 times n minus 2 is equal to 900. I'll divide by 180 to get n minus 2 is equal to 5. Then add 2, so n is 7, which means that what I have is a heptagon. So here's one for you to try. I have an 11-gon. So remember how we're going to do this. You should have it by now. It's 1620. 11 minus 2 is 9. 9 times 180 is 1620. The sum of the measures of the interior angles of a convex polygon is 1440. Classify the polygon by the number of sides. So if you think about this, what we do is divide 1440 by 180, and that is going to give me 8, and then add 2, so I have a decagon, 10 sides. We can use algebra to do this too. Find the value of x. Well, what I know is that this is a quadrilateral. So for a quadrilateral, my number of sides is, or my sum of the angles is 360. So I simply say x plus 108 plus 121 plus 59 is equal to 360. Simplify and solve to see that x is 72 degrees. So here's another one for you to try. If we look at this one, what we'll notice is that these two have the same measure, so x and x. So I have x plus x, which is 2x, plus 93 plus 156 plus 85 is equal to, now I need to know, I got 1, 2, 3, 4, 5 sides. So for my 5 sides, n minus 2 would be 3, and 3 times 180 is 540. And so I can solve this and see that each one of them is 103. The measures of 3 interior angles of a quadrilateral are 89, 110, and 46. Find the measure of the fourth. Since I have 4 sides, then I know that my sum is 360. So when I subtract, I get 115. The exterior angles. Remember from our study in triangles that an exterior angle is an angle which forms a linear pair with the interior angle if one side of the polygon is extended. Angle 1 is an interior angle, angle 2 is an exterior angle. I want you to take a sheet of paper and draw a convex polygon. Let's make it 5 sides. Create one exterior angle at each vertex and number them. So you should have 5 exterior angles if you did a pentagon. Cut out the exterior angles and put the vertices of these all together, and what you should see is they complete a circle for 360 degrees. That leads us to our next theorem, the polygon exterior angle theorem. The sum of the measures of the exterior angles of a convex polygon excuse me, one angle at each vertex is 360 degrees. That doesn't matter if what we're talking about is a triangle, a quadrilateral, a pentagon, or an 11-gon, or 27-gon. Still, if I take one exterior angle at each vertex, put them together, they will always add up to be 360 degrees. What is the value of this shown? Well, what I need to do is simply realize that they're all exterior angles, so add them up, equal to 360, combine my like terms, and then solve for x. X is 68. So the correct answer in this case would be B. So here's one for you to try. We've got 5 angles of a hexagon which has 6 sides. So simply add them together, subtract from 360. Example 5, the trampoline shown is shaped like a regular dodecagon. You have to remember how many sides is a dodecagon. Well, a decagon is 10, the dodecagon is 12. So we will say n minus 2 times 180, so that's 10 times 180, or 1800. Now, each interior angle, there are, what did we say, 12 of them? So we divide 1800 by 12, since this is a regular dodecagon. That means it's got equal angles, and equilateral and equiangular actually. And so if that's 150, if we use our sum on the outside is 360, divided by 12 is 30 degrees. So could you use another way to find the exterior angle. Linear pairs are supplementary, and since the interior angles measure 150, then the exterior angle must measure 30 degrees.